It is fully within the laws of physics for objects of alien origin to pass through or be stationed within the solar system, and even enter the Earth's atmosphere and its ocean. My guest today has appeared with us on Event Horizon many times. Indeed, he was the first guest ever on this show. But this time, Avi Loeb is in a rather unique setting, reporting to us on location regarding finding and trying to retrieve fragments of the first known interstellar meteor. And things are happening on that count as part of the greater framework of the Galileo project. Avi joins us today on expedition aboard the expeditionary vessel Silver Star, currently located off the coast of Papua New Guinea. This was not meant so much as an interview. It would have been difficult for Dr. Loeb to hear me under the circumstances of standing on the deck of the ship. Rather, the Galileo project is meant to be an open probe into technosignatures, be they UAP or interstellar objects of unknown origin. So here's a tour of the expedition so far, given by Dr. Loeb himself for you, the Event Horizon audience. I hope you enjoy.
You have fallen into Event Horizon with John Michael Gaudier.
Okay, so we are here in the meeting room. And we'll go down to the deck of the ship that is fittingly called Silver Star. It's quite remarkable. We got a ship which fits the mission of the expedition to retrieve the fragments of the first recognized interstellar meteor. We are on site planning for the next run, and let me show you around. This is the deck, and I will stand next to the winch. We have, as you can see, this wire that is connected to a sled. Let me show you the sled. So the wire basically goes through the A-frame that you see behind me and down into the water, connected through a triangle to the sled. And the sled has magnets that can assemble any magnetic particles or even bigger objects that are on the ocean floor. The depth of the ocean is somewhere between 1.7 kilometers up to 2.3 kilometers, depending on where we are. We are on site that was defined originally by the Department of Defense. They localized the area from the sensors that they used, and we were able to pinpoint much more accurately to within a kilometer or so the path along which the meteor fireball was noticed based on seismometer data that was assembled at Manus Island, which belongs to Papua New Guinea. And here you can see one of the sleds. As you can tell, I'll put the camera close to it. It's raining right now, so I'm wet, but you can see these are neodymium magnets, powerful magnets that collect any magnetic material. And of course, if we don't get magnetic materials, we also have plan B, which is a sluicing device that will basically filter out heavy particles. And so it must be made of very dense and tough material. So let's go and see the deck itself. You can see here preparations for the next run. We did 3 runs so far, and you can see the people associated with our crew preparing the sled. We want to put more heavy stuff on the sled so that it will sink to the bottom. One problem we had was that the sled was floating like a kite above the ocean floor, so we couldn't really scoop it effectively throughout the duration of the run. We got 2 effective runs at the meteor site, and you can see here it rains a significant fraction of the time, but every now and then it stops, and I'm jogging every morning at sunrise on this deck on my own at the place without moving around much because it's a bit slippery, as you can see. So now they're fitting more weights on the front triangle that is connected to the sled so that it will sit on the ocean floor when we send it to the 4th run. And let me show you around a little more. So this is the A-frame. You can see the winch cable currently anchored at the A-frame, but when we send the sled to its mission, it's basically hook. We connect it to the cable. You can see the cable here. So we connect it to this cable and then send it into the ocean and let it sink. It has roughly 200 kilograms. And now we are adding more weight because apparently it's floating a bit above the ocean floor. We just looked at the footage from the cameras. There are cameras on the triangle that you see here. They're sitting inside, video cameras, and telling us what the sled is doing. And also, the hope is that eventually, once we master the technique, we could tell if there are objects that are big along the path of the sled. Because, you know, if it was a technological relic, which is a reasonable possibility because this interstellar meteor was moving faster than 95% of all the stars in the vicinity of the sun. So potentially it benefited from some artificial propulsion. But moreover, it was tougher than all other space rocks, which you would expect for an artificial alloy, like stainless steel, even tougher materials that we produce technologically. So we want to figure out if there are any fragments that would indicate a technological origin. And in principle, it's possible that the core of the object survived the entry through the Earth's atmosphere, just like spacecrafts that return back to Earth survive the re-entry. So in principle, you can design technologically an object that would have integrity, and only the outer layers would be ripped off and would appear in the fireball as releasing a lot of energy. And that doesn't mean that the core was disintegrating during the process of entry. So if there is any technological gadget, we could potentially see it with these cameras. And of course, then the fundamental question is, what do we do if it has buttons? Should we press any button? And I asked this question to my class at Harvard a month ago. I would be very cautious of pressing any button if you find a technological gadget. Of course, if it's too big, we can't lift it with this sled. The magnets are not strong enough, but we can come back and visit the area and do it again. And in fact, if we do see a big object, we know where it is, so we can come back with a better technique, like an ROV. So this is the deck, as you can see. And it's very cloudy here. We can talk a little bit about what we found so far. Mostly volcanic ashes. So we went to a control point to go to a place where you don't expect anything unusual and see what you find there, because that establishes the background. And so we did identify volcanic ashes at a control site. And it's basically a powder of very tiny particles, roughly 1/10 of a millimeter in size or less. And you can collect them from the magnets, from the rims of the magnets. You can see here. And I used a brush, a painter's brush that Jeff Wynn, that is married to an artist, wrote. He basically stole it from his wife, and it happened to be the most effective way, or most effective tool of getting those volcanic ashes off the magnet. So in the controlled sample, we found volcanic ashes. Today, in run 3, we found volcanic ashes. As the Bible says, from ashes to ashes. There wasn't much of a transition in this run, but in the first run, which was actually closer to the path that was most likely the fireball path of the first interstellar meteor, we did find some other things. One of them, the most unusual, was a wire that was warped, curled, and was made of manganese and platinum, which in a combination that is very rare for any commercial products on Earth. So That's very intriguing. And if we find more of these wires and we don't find them, that's very important. We don't find them in a control region, then it could be a technosignature, a new type of a technosignature. Another thing I wanted to bring up is when we find particles, we could find radioactive elements in them, isotopes, and those isotopes could have different half-lives. And so suppose we find material from interstellar space and we find isotopes that tell us that the journey could not have lasted longer than the lifetime of those isotopes. So there is a maximum distance from where they came, but we can also get a minimum distance. If we don't find some other isotopes, that means that it must have originated farther than the set distance. And by that method, we can actually figure out the distance of the source of the material that we identify, and we know the direction of the velocity of this interstellar meteor, so we can figure out which location in space it came from. In principle, pinpoint to the group of stars that could potentially have been the source of the object, which is remarkable. You couldn't do that before. This is a new technique, and I thought about it just yesterday as an original idea. We never had an interstellar object that arrived to Earth in a well-defined trajectory so that we can relate it to a star or a group of stars. And we have a potential of doing that, aside from finding a technosignature. So altogether, it's very exciting. We're embarking on a new frontier. There are exceptional people involved in the team, in the research team, and some of them are working on the technical details, as you can see here. Some of them are navigating the boat in the proper direction. All of them are very experienced. This expedition was quite expensive, $1.5 million. We do have the funder with us, Charles Hoskinson. In fact, I spent several hours speaking with him along the ride here, which was on his private jet. That was a very long ride, altogether 16 hours from Boston to Papua New Guinea. But it's very exciting. I don't sleep much. I enjoy jogging in the early morning at sunrise. And it's a thrilling experience. That's the way science is done. Some of the runs do not produce anything exciting, and that's, you don't always get what you wish for in science. But you must wish to find something, otherwise you will never discover it. So when people say extraordinary claims require extraordinary evidence, they are not really seeking the evidence. You have to wish for to find it. And that's the beauty of this particular expedition, that we are seeking the evidence. There was a meteor here that moved too fast to be bound to the sun, above the escape speed from the solar system. It exploded right here almost a decade ago, January 8, 2014. If we were here at the time, you would see a giant fireball because it released 3% of the Hiroshima atomic bomb energy. And it produced a very bright fireball, but the core of the object could have continued along the path, and it may be right here somewhere on the ocean floor. And so we are just seeking those materials. And the beauty about the ocean is there wasn't much happening over the past decade on the ocean floor. It's made of mud. There is some residues of volcanic ashes from, centuries ago, but other than that, not much action at the depth of roughly 2 kilometers. So we are very fortunate that it landed here. And in fact, Papua New Guinea has 850 languages on its islands. It's the largest concentration of languages on Earth. And if we find a technological gadget with an inscription on it, we will add one additional language here. And, we're located about 85 kilometers away from Manus Island, part of Papua New Guinea, where the seismometer happened to be. Very luckily, we were able to trace the path of the interstellar meteor, which was in the same direction that is tangent to the direction of Manus Island. So it means that we were able to pinpoint the actual path. That's just pure luck. That the distance of the meteor was constant along its path relative to the seismometer. So we were lucky in that regard, so we can pinpoint where the meteor went. And so the first run was just along this path. We found this wire, which is very unusual. The second run was not successful because we were basically floating above the surface, not much contact with the ocean floor. And the third run, just an hour ago, did touch the ocean floor, but was away from the most likely path. So we found only ashes. I was asked by my wife, right here on the deck, on the first run, she said, "Are you excited?" And I said, it feels just like my first sexual experience. I didn't know what to expect. I don't know what to expect. It's the first contact with an interstellar object. I don't know what we might find. I'm completely agnostic. We might not find anything, but we better try. So this is the way science is done. It's remarkable in terms of the scope of the project. We're using a very primitive approach, which is basically a sled with a group of magnets to go across the ocean floor and collect all magnetic materials. If that's not successful after the first week, we'll go to a sluicing device which separates particles by their density and maybe find something else. And of course, we can come back again and visit the place. We have a second meteor that we might be looking for. And there is a filming crew, as you see behind me, taking a video of us. And they are very good, this filming crew. I had about 40 filmmakers and producers that contacted me. In fact, one of them even yesterday asking me if, he was an Emmy-winning filmmaker, wanted to join us on the expedition. I said, too late. We already have an exceptional filming crew. You hopefully will see the documentary in about a year or two. There will be also a play that will be completed after the summer, starting to show hopefully later this fall about this research. And moreover, just the day before I joined the jet on the way to Papua New Guinea, I got a phone call from the owner of the high definition display on in Times Square, basically on the intersection of 43rd Street and Broadway, just the middle of Times Square, this giant display, and he's offered us for practically freely to put the Galileo Project video on it and for 15 seconds. So we now have this access, and if we find something in this expedition that looks unusual, let's say another wire or two or a few more extraordinary things, we can put them on display in New York City so that millions of people will see them instantly. And we will keep everyone posted. As I always said, what we are doing is completely transparent. Anyone will know what we are finding and how the scientific method works, because it's an educational exercise, both for the public about how science is done, how you attempt to search for something, you don't always find it, and also for my fellow scientists. They have a very strong opinion. Some of them told me, it's not worth your time, why go there? And that's my lesson for them, that if you don't search, you will not discover anything. So it's an educational experience, both for my fellow scientists and the general public about how science is done. And, we are dependent as to what is there down in the ocean. We don't know. And we'll bring already enrolled as an intern to help with the analysis of the sample that we bring back. So we're very invested. We have exceptional members on the team, a geologist. We have an analyzer that is using an X-ray fluorescence device to figure out the composition. We also have a gamma ray detector to see what kind of gamma rays, very energetic photons might be emitted by radioactive isotopes. So stay tuned. We are only in the 4th day today. We are here for 2 weeks, and we will do our best. You can see the microphone just behind me, and the camera looking to the side, and you can see the work being done as we speak on adding weight to the sled, because apparently it was floating above the surface most of the run, the 3rd run. Some weight to it, potentially the anchor chain that you can see here, but we're not sure yet. Start with adding some lead to the device. So these are the updates as of now, and of course it's work in progress. We will keep sending the sled into the ocean again and again and again in the next 10 days or so, and we'll report back. Hopefully we'll have more than 10 additional runs, maybe a dozen, and each of them is a new adventure. We don't know what we might find. So stay tuned. It's exciting, and we will do our best to bring something new back.
Now, Dr. Loeb, one quick question. So you found the wire, and
we can go to a quieter area. By
sure.
the way, just you hear the noise. That's the engine, and there is the bow thruster of the ship that gets operated when we. Oh, here is Rob McCallum, by the way, the coordinator of this.
Hi, how are you? I'll see you on the stage.
Yeah, he is the most accomplished ocean explorer on our planet. So he joined us to lead this expedition, and we're very lucky to have him, including the founder himself, who is on the boat. I'm going back to the kitchen. We have an amazing cook. I hope I will not gain too much weight and see the kitchen. I'll go up to the meeting room so that we can speak more quietly. The living quarters are quite small. That's the only aspect, but you can see the meeting room. It's quite comfortable. And let me sit on the sofa so we can chat. So please go ahead.
Now, a couple of additional questions. You covered most of everything, but a couple of additional questions is the wire. I noticed that it contains a small amount of cerium, which struck me as odd because it's very reactive. So do you think that that's one of the weird aspects of this is that content as well?
Yeah, it's one of the weird aspects. Let me show you how we measure those elements. So we'll go to the upper deck, upper floor. We're going there right now. Good exercise. And let me show you. So there is this X-ray fluorescence device that you can see right here. And what it does is it shines X-rays on the sample, and then the X-rays excite whatever elements are on the surface, a millimeter from the surface. And in response, the material emits some X-rays that we can use to identify the composition. So that's the composition of the surface. But then we have a gammameter, which basically allows us to figure out the radioactive elements within the material. And this is the table where Ryan Weed, one of the members, sits, and that's his laptop. You can see, do not turn off. And the navigation of the ship is done right here. We have the captain in front of us. And oh, look who we found here. Jeff Wynn, the geologist of the expedition.
I've been called worse.
And as you can see, his shirt says the Galileo Project. and the name of the boat, Silver Star, and on the back it's Interstellar Expedition. And that's what the team members were. Here you see next to him our founder, Charles Hoskinson. Nice to see you. Art Wright, our navigator, very experienced. He led the destroyer during the Vietnam War, was extremely successful, and then decided to continue exploring the oceans on expeditions like this one, which he's very excited about, and we are very fortunate to have him with us. And it's really a treat for me to learn from him. He always reminds me of my father. He's very wise, uses a few words, and he's always on target. So thank you, Art. And here is Ryan Reed looking at an image of one of the particles we collected today.
It's a foraminifera. It's a organic.
Oh, it's an organic particle. So today was not, the harvest was particularly impressive. And this is the camera person looking at you. So all together, we are getting ready now to have a team meeting. So I cannot speak for much longer. Did you have any other question?
Nope. My last question is this. When you get back to shore, what are you going to do with the wire and any other samples? Are you going to do much more in-depth testing? And
yeah, we secured the storage at the Harvard College Observatory. We'll keep a close watch on everything we collect here so that nothing will be contaminated to maintain the scientific integrity of the analysis. And we can loan those materials to any team that might want to analyze them. So we will do it the scientific way.
One last thing before we go. Have you managed to avoid the seasickness?
Yes.
Excellent.
I was never on a ship, but I did consume a tablet of Bonin, which is a very convenient thing to take, and I don't feel anything. Maybe it's the excitement about the science. Who knows? Doesn't matter. Yeah.
I wish you continued good luck, and when you get back to shore, I look forward to having another chat with you about the results.
Thanks for joining us today. Bye-bye.
If you would like to follow the daily progress and discoveries of the expedition as they happen, Avi is chronicling the voyage in near real time with multiple posts each day at his blog at avi-loeb.medium.com for free and in the open, and with the material analyses they can do on board the ship. Additionally, check out the Galileo Project's homepage at projects.iq.harvard.edu/galileo/home. Things do not get more exciting than this, so stay tuned to Event Horizon for any new developments in the analyses of any recovered unusual materials from this expedition.